Okay, today I'm going to explain how we do critical regions when we're doing a hypothesis test with the binomial distribution. Okay, I'm actually going to explain the whole hypothesis testing thing anyway. This example is from a past AS paper, but you do need to know the skill whether you're doing AS or A level. Okay, so in this question, we're investigating the proportion of adults that have an allergy. Now, hypothesis testing, you're always going to have a null hypothesis. This just means your previous knowledge, your prior thinking, or just what you used to think was true, or so in this case, past information. So past information shows 25% of adults have an allergy. So in this question, it actually tells you, but you'd usually have to write it down yourself. Your null hypothesis is that prior thinking, so the proportion or probability is 25%. Binomial, it will always be H0 colon P equals. The H1 is you have a different idea. You think something different and it's 25%. Maybe you reckon it's more than that, maybe less than, maybe you don't know and it's just different. So it'll always be P and it'll be greater than, or maybe less than, or not equal to. In this case, Ryan believes the proportion is different from 25%. So they don't believe, particularly whether it's more or less, just different. So we have not equal to. Hopefully you've seen this idea before, but this is what's known as a two-tailed test. So I'll get into the specifics of what that means in a little bit. Okay, that's actually my alternative hypothesis. That's my answer for part A, and B is just doing the rest of the test. So you would first just define your variable, which is like the experiment you're doing in this case. So to test Ryland's belief, what they're going to do, they're going to take 50 adults and see how many have the allergy. And the logical thing to do, right? If 49 out of those 50 adults have the allergy, obviously that's very good evidence that it's not 25%. Also, if only one of them had it, that would also be good evidence, right? So that's what we're trying to find. Are we going to see good evidence? So we start by saying let X be the number of adults in the sample of 50 who have the allergy. And then before anything else, what you do is, in these questions, you assume H0. So all your calculations are based on the past information being true. So based on a probability of 25%. Oops, I've already said that one. And then for a method mark, make sure you get this one in. How can we model this number of adults? Well, we are picking 50 adults, and every one of those adults, according to H0, has a 25% probability of having the allergy. So if I'm counting how many out of those 50 have the allergy, that's exactly the scenario for a binomial distribution. Okay, so when we're counting successes, when we're doing the same trial over and over again. Okay, so first thing to think about, and you have to do this for a two-tailed test, and it's even useful still for a one-tailed test. First thing to think about is what's the expected number of adults to have this allergy? Okay, 50 adults, 25% of it happening. The expected is going to be NP. In this case, 50 times 0.25. Essentially just 25% of 50, right? That's how many we should expect to have the allergy. In this case, it's 12.5 adults out of that 50. Okay, I'm going to add this on a little diagram. And, okay, binomial distribution is discrete. You can only have, 12 adults, 13 adults. It can't be all these decimals. So technically, it would be a series of discrete bars to show my probability. I'm just going to draw it with a curve. It's going to be a little bit simpler. So it's going to be a lot better, okay? Because 12.5 was the expected number of adults having the allergy, I'm going to put 12.5 right in the middle here. So the area under the graph is going to represent probability. Now, two types of hypothesis testing questions. It's important you know which type you're doing. One type is where you are finding a critical region, and you know that's the question because it will explicitly ask for it. So this is a critical region question because it asks you to find a critical region, okay? Second type is when it does not ask you to find a critical region. That's actually simpler, and that's what I'm going to start off by talking about. So if it does not ask you to find a critical region, what it will do is it will tell you the outcome of an experiment. So in this case, it would tell you how many of those adults had the allergy. And I'm going to make something up. Let's say it told you that 18 of the adults had an allergy. Okay, so 18 adults. And it would ask you, is that good evidence that that it's not 25%? So obviously it is more than expected. but the question is how much more. And to calculate this, what you do, you put your 18 on your diagram, and you calculate the area, which is like away from the mean. So the mean is 12.5, the expected. You calculate this small tail here, okay, to the right of 18. And if instead the question said, 8 adults had the allergy, because 8 is to the left of this mean, you would go to the left of 8. Okay, so that's how you know which side to go to. You just go further away from the mean. You can think of it as like, being more extreme, right? 18 is already more than average, so we're going to say 18 or more. And what you would do in a non-critical region question, they would tell you 18 adults had in this experiment, and you would calculate this number, the probability that you saw that result or more extreme. Okay, it's always going to be this kind of cumulative probability. And let's just say, for the sake of argument, that this turned out to be, let's say, like 1 and a bit percent. Okay, 1.2%. According to H0, there's only a 1% chance that you see 18 or more adults with the allergy. And you compare this percentage to the significance level. Essentially, this is a very small percentage, small probability, right? So it's probably good evidence that it's not 25% anymore. And the question is, how small does the probability have to be for it to be good evidence? That's the sig level. You've probably seen before as well, on a two-tailed test, you actually need to half the significance level, so it becomes 2.5%. Okay, so in this case, this is like 1.2% over here. This is less than 2.5%. So what you would do, you would reject your H0, reject the fact that it's 25%. You think it's not 25%, and you have to write a concluding statement. To contrast that, if you had instead been told not 18 adults, but told 14 adults, and you calculated the area to the right of 14, and if the area to the right of 14, when you calculate it, was something like 7%, that was more than the significant level, this is now not unlikely enough, okay? 7% is not so unlikely that you would change your prior thinking. So this will lead you to accepting H0, you would not change your mind. That's the regular hypothesis testing with no critical region. You just do one calculation, right? Whichever one you're told. So if you're told 14, you do this one. If you're told 18, you do this one. And like I said, if you're told 9, right, or something, you would calculate this one, x less than equal to 9. And you make a comparison and you're done. On a critical region, what you would do is you are not told the 14 or the 18 or the 9. You're not told what the actual outcome of the experiment was. On a critical region, it's your job to find out what outcome of this experiment would lead you to reject H0 and which one would lead you to accept H0. Okay? So we said that 2.5% was the kind of threshold, right? If you're less than that percentage, you would reject. If you're more, you would accept. So there will be some numbers which are past this 2.5% threshold. Let's say this area was 2.5%. And some numbers which are before it. Okay? We've got to find out which is which. So say we know it's 12.5 here. Again, I'm making these numbers up for now. We'll do the actual calculations in just a second. Let's say you calculated that the probability of x being greater than or equal to 17 was more than 2.5%. Okay, so 17 was more than 2.5%. So this would lead you to accept H0. It's not extreme enough for you to change your mind. But then say that 18 crossed over the threshold, and being more than 18, that was now less than 2.5%, it would lead you to reject H0. Okay. Again, making these numbers up, we'll do the calculation in a second. So 16 is over here, and 19 is over here, and so on. Now in this case, once you've found this 17 and 18 that are like either side of this line, you now know all the numbers that make you reject, right? If x was 19, that's even less probability of being more than or equal to 19 than it was for 18. That's definitely less than 2.5%. And 20 is even less than that. So if x was 18, 19, 20, 21, etc., those would all lead you to reject H0. And this, you might want to call it the rejection region. It's got a different name. It's called the critical region. Okay, so the critical region is just like the region the rejection region, okay, the set of x values that make you reject H0. And then on the other side of it, the set of values that make you accept H0, so in this case it would be 17 or less, would be the acceptance region. Okay, so that's all these definitions are. Which values of x, which outcomes of that experiment would make you reject the hypothesis, and which would make you accept. Okay. So I think that's all I want to say here. Yep. So we can actually go and try and do this on our specific question now. Okay. So let's find the critical region on this test. So I'm going to carry on B down here. Now we've got the idea, we know what we're looking for, we can actually do calculations. Let's draw this properly, nice and horizontal. So a picture like this is absolutely essential to help you get things straight, make sure you're doing the right calculations. 12.5, we calculated that was the average, the expected. Critical region, you are finding these numbers like around 18 or wherever it was. Now, on a two-tailed test, there's actually going to be, the critical region is going to be split into two pieces. There's a lower region down here and an upper region up here. And this is why we split the significance level in half. Okay? Because it's 2.5% on the lower tail down here and 2.5% on the upper tail up here. And together that makes 5%. Now, one more thing I should have just said, but on this example down on the right, there's one more piece of terminology, and that is the critical value. The critical value is just this first value that's inside the critical region. So it's the 18. It's the critical value, right? That's the one where you reject, but you would accept at 17. Okay. So two-tailed test, there's going to be actually two critical values, okay? There's going to be some number here, which is an accept, but then a number here, which is reject, and the same on the upper tail. We've got to find what these numbers are. And the only thing you can do is just take a completely blind guess. So I'm going to start on the lower tail. So I'm trying to find values for these two numbers. You need both of them. Okay. And because these are to the left of the mean, I'm always calculating the area to the left of these points. Yeah, away from the mean, like we talked about. I'm going to guess 8. I just guessed a number less than 12.5, okay? There's nothing special to that. So because I'm to the left of the mean, I'm going to calculate the area to the left of 8. Now, the distribution I'm using, remember, x was just binomial, 50 and 0.25. So I can use that in my calculator. It's always going to be cumulative distribution for the hypothesis testing. So I'm going to put x equals 8, n equals 50, and p equals 0.25. And my probability is, let's see here, 0.916. So 0.0916. Okay. In this question, because I need to be less than 2.5% to reject, this is not less than 2.5%. This is still an accept H0. Okay, so I need to go further down. So 8 is somewhere here, for example. Let's guess 7. Okay, so less than equal to 7. You just go and change that number in your calculator. You can also use a list function to calculate a load at once, once you're comfortable with this. This comes out to like 4.5%, something like that, 0.0453. It's still going to be an accept H0, but we're getting closer. Okay. If I started out way too high, like, this would be like 50% or 40%, you could obviously jump quite a few. 9% is pretty close. I'm only going down in ones. Let's try 6. Less than equal to 6 gives me, okay. So this is now 1.9%. Yeah. This is less than that 2.5%. This is now a reject H0 situation. Okay. So on my picture, 7 was a number here, and 6 was a number here. 6 was the first value that made me reject. And if I carried on and did 5, as you can see, and 4 and 3, these numbers are just getting smaller and smaller. So 5, 4, 3, 2, they're all going to be reject. So the critical value is x equals 6, and this part of the critical region will be x less than equal to 6. Okay. we're only halfway there. If this is a one-tail test, you'll just do the one tail, and to know which tail you would do, you'd base it on exactly whether you had a greater than here or a less than here. So if you had greater than here, you do the upper tail, less than would be lower tail. It's not equal to, so we've got to do both tails. So upper tail, you've got to guess again, right? We're going to find these two values. Binomials not always symmetric, but a good rule of thumb is try and make it symmetric for your first guess. So it turns out like 6 and 7 with the critical ones down here, they're like, 5 away from 12.5. So I'll start at maybe like 17, 18, about, so it's the same distance away from the mean. May as well start there. Okay, let's guess 17. So what I want to do is I calculate the probability to x is to the right now of 17, because now we're up here, we're going to the right, we're to the right. Remember, in a binomial, on most calculators, to do greater than or equal to them, you're going to have to do 1 minus less than or equal than the number below. Right, so greater than or equal to 17 is less than or equal to 16 with a 1 minus. So when I put 16 in my calculator, I get 0.901 and so on. 0.9017. So that's like, I would type this in my calculator, it's like 8 or 9%. That's going to be more than my 2.5%. Okay, so this probability is too big. 17 is somewhere over here. Okay, this is still an acceptational. So let's try 18. Let's try 19. Let's keep going. So greater than or equal to 18, I would do 1 minus less than or equal to 17. So even though I'm testing 18, in my calculator, I'm entering 17. Okay, so follow along with your calculator. So that's 1 minus 0.944. 5. That's still greater than 2.5%. So let's keep going. Greater than or equal to 19. So greater than or equal to 19 is 1 minus less than or equal to 18. So I'm typing in 18. Okay, we're still more than 2.5%. I can tell from my calculator already. Okay. Greater than or equal to 18. I've done 18. What am I doing? Let's try 20. Okay. I should actually write this number down. So 1 minus 18. Sorry. This was 1 minus 0.971, which is 0.029. And greater than or equal to 20, I'm typing in 19. I'm getting 1 minus 0.986, which is 0.014, which is now less. Okay. So on my picture, 20 was a reject H0. 19 was an accept H0. Okay, so even though the number in the calculator was 18, I was testing 19 still. So 19 was to the left and 20 was to the right. So this number was 19 and this number was 20. So 20 was my critical value. Okay. Now, there is one small detail that can sometimes happen in these questions that I haven't talked about so far, and you might have already noticed. This is normally how you define your critical value. Okay, it's the first one in the region. This is how you do your critical region. Okay, the first one is less than 2.5%. Sometimes, and only if the question specifically says, instead of taking the first value inside the region, it will say, like it does in this question, the probability in each tail should be as close to 2.5% as possible. So it's a very slight alteration. Okay, instead of picking the number, for example, down here, we picked 6 because it was the first one that was less than 2.5%. You would look at your two numbers on either side, and whichever one gave you a probability closer to 2.5% would be your critical value. not whichever one was less. So in this case, the probability of less than or equal to 6 was 1.94%. And 1.94%, that is closer to this one, which is 4.53%. So it's closer to what we wanted, which was 2.5%, than 4.53%. Okay, 1.94 closer, 4.53, so we took the one that's closer. Up here, usually it will just be 20, the first one that's less. We're going to say which one out of these two is closer to 2.5%, and actually, here it does make a difference. This out of the two numbers is actually closer to 2.5%. So even though it wouldn't give you, technically it wouldn't give you a reject on a normal hypothesis test, you're going to use x equals 19. Again, only when the question specifically states this. If it does not, you just do the first one in the region. So, now I can state my critical region finally. I've done all my work. The critical region is, on the lower tail, it was 6 and below. Yeah. And on the upper tail, not 20 and above, but 19 and above, because of this thing about being as close as possible. So x can be less than or equal to 6, or x can be greater than or equal to 19. There's my critical region. And the acceptance region, if you're interested, would be between 7 and 18. Okay, so x is greater than or equal to 7, less than or equal to 18 would be the acceptance region. But we've got to find a critical region. Okay. Part C. State the probability of incorrectly rejecting H0 for this test. This is a one marker they can often ask. Sometimes they ask the exact same thing, but they phrase it differently. Sometimes they will ask for the actual significance level. Okay, they may ask for it like that. They may ask probability of incorrectly rejecting H0. All you need to do is add together your two values you've got, your sort of p-values. So in this case, the actual values I considered were, well, which values did I consider to reject? It was less than or equal to 6, which was 0.0194. That's an important value. And the value I considered on the upper tail was greater than or equal to 19, which is this one. You can see there are two numbers that correlate to these two. To part C. The actual significance level is less than or equal to 6. I've already forgot the number. It was 0.0194. And greater than or equal to 19, that came with a probability of 0.029. And let's just add that together. I've kind of been a bit inconsistent here, haven't I? I've done 4dp and 3dp. So I guess I'll do the final answer to 3dp. My calculator's not working great in a minute, so that's why I wasn't able to do a few more. But you would ideally do a few more, maybe one more decimal place over here. Okay, yeah, so it's just this area that we've decided was our critical region. Yeah, so our critical region we decided was 6 or below, or 19 or above. And the actual significance level is just the area of the critical region, or the probability of falling inside this critical region in this distribution, which was assuming H0. So that's why it says incorrectly rejecting H0, because the probability that you fall inside the rejection region when H0 is true, which would be an incorrect rejection. Okay, so rather than find that 10 adults have the allergy, state the conclusion, we've done all the work, right? 10 adults have the allergy. Well, we decided if you were 6 or fewer, or if you were 19 or more, we would say reject. So 10 adults, x equals 10, that is not inside the critical region. Okay? So I'm not going to reject H0, I accept H0. And then let's write conclusion in context. Your conclusion context is there is or there is not sufficient evidence. Because I'm accepting H0, I'm accepting that it's 25%. So I'm saying there is no evidence or not sufficient evidence that it's gone anything different than 25%. So my conclusion is there is not sufficient evidence. Sorry, my pen is being weird here. There is not sufficient evidence that and you have to link it to the context. So proportion of adults with the allergy has changed. So you can't say there's not sufficient evidence to support H1 or to reject H0, okay? That does not say the context of the question. We talk about proportion of adults with an allergy and change because of the two-tailed test, okay? So even though this is only a two-tailed critical region test, hopefully with this video, you can now go and answer any critical region test, or even ones without critical region where you just, like I mentioned at the start, just state your conclusion. And then after your conclusion, you just have to write a statement exactly what I've written below. Okay? So let me know if you want me to do maybe more examples or one without critical region, or maybe we can do the similar thing for a normal distribution. Just let me know. Okay, thank you.